Limit laws are simple, easy, and intuitive to apply. Let's have a look at them. The first limit law says pull the constant multiplier to the outside. You'll just evaluate the limit of the function first, then multiply. The second limit law says the limit of the sum is the sum of the limits. In other words, you can apply the limit to each function separately. Let's apply the two limit laws to this example problem. Since the limit of the sums is the sum of the limits, let's apply the limit to each function separately. We've applied it to f of x, separate now from g of x. Now let's use limit law 1 and pull out the constant multiplier from each of those two functions. Next, we want to use the information given to us in the problem about the value of the limits. We simply apply that to these two parts of the problem here. Using these values, we evaluate. So we write 4 times 5, because that's the value of the limit for f, plus 2 times -2, because that's the limit for g of x, and then we do the sum, 20 plus -4, and we get 16, and we've answered the question. Let's look at the third limit law. The limit of the product is the product of the limits. Therefore, what we can do is apply the limit to each of the products separately. Let's look at another example. In this problem, we need to find the limit as x goes to 3 of 6 times the product of f of x and g of x. First, let's observe that we have a constant multiplier of 6, and let's pull that out. Next, let's use the limit law number 3, and let's separate f of x from g of x and give each of them their own separate limit. Finally, let's evaluate these limits, and looks like we're going to get 48. That's our answer. Let's look at another limit law, the fourth one. That one involves quotients, and we want to say the limit of the quotient is also the quotient of the limit. Let's look at an example that uses this limit law. We just need to make sure the denominator does not equal 0. Okay, let's find a spot to write on. Okay, here's our problem. We're supposed to find the limit as x goes to 2 of a quotient f of x over g of x. So separately, let's take the limit of the top as x goes to 2 and over the bottom, limit x goes to 2 of g of x. And then we look back and we see what were the values that given to us. And we were given 8, and for g of x in the denominator 2. So 8 divided by 2 is 4, and it looks like we found the answer. Okay, pretty straightforward. Now let's go back and look at limit law number 5 that says for any constant k, the limit as x goes to c of k equals k. Well, why would that be? Let's look. For this one, let's use some graph paper. So we'll create a graph with x and y, and I'm going to create a straight horizontal line, y equals k. Now, on this line, we have various points, but as x goes to c, and any c, so we can just pick c's down here on the x-axis. As x goes to any c value, look what y does. Well, it always stays at k because we have the points c comma k. So the limit as x goes to c of k is always k. Let's look at and understand that last limit law as well from the standpoint of a graph. Let's look at an xy graph, and I'm sketching right now the graph of y equals x. Now let's place some points, x equals c, out there on the x-axis, and what does y do as x approaches any c value? And as you can see, all these ordered pairs are just c comma c. So as x goes to c, y goes to c, and therefore we have our answer. So I hope you understand these limit laws a little bit better. Thanks for watching, and subscribe for more great math videos.